Okay, hello everyone. I'm going to go through question 10 from exercise 3B. So this is very important that we understand this process because this is a very common format. The fifth term of an arithmetic sequence, so the fifth term of an arithmetic sequence is 33, the 10th term is 68, and the sum of the first n terms is 2225. Show that 7n squared add 3n minus 4,450 equals 0. Okay, well, they're not really giving me that much information, are they? They're telling me that the fifth term is that, the 10th term is that. So I don't know what the first term is, my A, and I don't know what the difference between them is either, i.e. my D. But I'm going to use this piece of information to set up an equation, and I'm going to use UN. So my whatever term is equal to A plus n minus 1 times D. Well, this is in this one here, this is my fifth term. So I know that my fifth term is 33. So let's rewrite this. So so my 33, my term is 33. Don't know what my first term is, my A, plus, well, this is the fifth term, so n is equal to 5, take away 1 times the difference D, 33 equals A plus 4D. Problem, I have two unknowns and one equation. I can't solve this, okay, unless I have another one, and then I can make some simultaneous equations. So for this one, I know that the 10th term, that's what that notation means, the 10th term is equal to 68. Therefore, 68 equals A, don't know what that is, plus n, well, it's my 10th term, so n is equal to 10, minus 1 times the difference. 68 equals A plus 9D. Okay, right, so I have two equations, two unknowns. I've got 68 is equal to A plus 9D. I've got 33 is equal to A plus 4D. Nice simultaneous equations, because when I subtract these, the a's are just going to cancel. This leaves me with 35 equals 5D. Therefore, D equals 7. Then when I substitute in D equals 7 into either this equation or this equation, you'll get that A equals 5. Yeah, so after you've substituted in D equals 7 into this or this, you'll also get that A equals 5. So I now know that D equals 7 and A equals 5. Well, that opens up a lot of doors for us because the formulas require typically A and D. So what two formulas have we got? Well, let's look at this third one now. So the sum of the first n terms is this. Well, the sum of however many, I can use one of two formulas. I can use Sn equals, let's start with this one, n over 2 times the sum of A. I'll make that clear that that's an L, yeah? So that's saying for the sum of however many terms is equal to however many terms there are divided by 2 multiplied by the first term add the last term. Have I got the last? I've got the first term. I know the first term's 5, but I haven't got the last term anywhere, so I have a problem. I have a problem, therefore I can't use this formula. If I had the last term, I would be able to use that formula, but I haven't, so I'll have to use the other formula. This formula is n over 2 times multiplied by, I shouldn't use, that's bad mathematical language, 2a plus n minus 1 multiplied by d. Substitute in what we have. So the sum of the first n terms is 2,225. So the sum of n terms equals 2,225. So let's rewrite this equation, but equate it to 2,225 equals n over 2 multiplied by 2 lots of A. 2 lots of A is 2 lots of 5 plus n. Don't know what that is, so this will just be n minus 1 multiplied, all of that multiplied by 7. Typically we put that 7 first, yeah? Close bracket. Okay, so if I multiplied all through by 2, that would basically get rid of that. Remember, this is the same as if all of it was over 2, because this is being multiplied by all of it. So 2 times 2,225 is 4,500. Sorry, 4,450 is equal to n times 10. In fact, let me just do it like this first so I don't confuse you. 2 times 5 is 10. Add 7 times n is 7n. 7 times minus 1 is minus 7. That's going to give me, if I expand that bracket, 4,450 equals 10n. Oh no, let's make this a bit nicer actually. N multiplied 10, take away 7 is 3. Add 7n. I'm sure you could probably do it from this point, guys. I don't know why I've gone into this much detail, but I have started, so I'll finish. Plus 7n squared, looking good. Equate to 0 and we'll get 7n squared. Add 3n minus 4,450 is equal to 0. So I've therefore shown that. Job done. And part B said, hence find the value of n. Well, this is just a quadratic equation. Solve to find n, and you should have got n is equal to 25. Remember, n must be a positive solution. If it appears in a sequence, it must be positive n. So n was equal to 25 when you put these values into your quadratic formula. Hope that helps, guys.